In this section, we'll solve equations that aren't exactly quadratic, but they're what's called quadratic in form. So what I want us to recognize is even though this equation here, x to the fourth minus 10x squared minus 11 equals 0, even though it's not like an x squared equation, you can still notice that the first term has exponent, which is twice the second term's exponent. So the method for solving these equations is to do a substitution. Let's say u be the x squared term. Then, so basically you look at the middle, if you line everything up in order, then whatever the middle variable term is, we'll let u be that, so that u squared would be x squared squared, or x to the fourth. Then we can rewrite this equation. Instead of x to the fourth, we could write u squared minus 10. Instead of x squared, you could write u minus 11 equals 0. And here's a quadratic equation, and you can solve it any way you like. I would prefer to factor because I can think of two numbers that multiply to negative 11 and add to negative 10. That would be negative 11 and a positive 1, right? So this would factor like u minus 11, u plus 1 equals 0. And I can solve that pretty easily. U minus 11 equals 0, and u plus 1 equals 0. So u would be 11, or u would be negative 1. Okay, we're not done with the problem, though, because I have the solution for the u equation, but I need a solution for the x equation. So what I'll do is, remember the substitution we made, let u be x squared. I'm going to take my two answers here, u equals 11, or u equals negative 1, and instead of u, I'm going to again back replace u with x squared. So I get x squared equals 11, or x squared equals negative 1. And now I can solve those equations. This one I can solve by taking the square root of both sides. You get x equals plus or minus the square root of 11. Or, taking the square root of both sides here, you get x equals plus or minus the square root of negative 1, which I know that to be the complex number I. So now notice I have four answers. I got positive root 11, negative root 11, positive I, or negative I. So there are four solutions to this equation. Okay. Notice the important part. First, line up all your terms with the exponents, the largest exponent first. If you recognize that the first exponent is twice the second exponent, then you make the substitution. U could be the second variable term, and then double check that u squared would be the first variable term with its exponent. Make that substitution and solve that equation, and then go back, resubstitute, and solve those equations. Let's do this in the next example. In this example, you have a plus 4 squared minus 9 times a plus 4 minus 36 equals 0. So notice you have three big terms. The middle term has this a plus 4 in parentheses. Think of that as one object. And the first term is the square of that. So we can make this substitution. Let u be a plus 4. And then notice that u squared would then be a plus 4 squared. So with this substitution, this first term, a plus 4 squared, that's my u squared, minus 9 times u minus 36 equals 0. Now I have a quadratic just in u. And then can I think of two numbers that multiply to the negative 36 and add to negative 9? I'm thinking maybe negative 12 and positive 3. Yep, those guys add to negative 9 and multiply to negative 36. So this factors like u minus 12 times u plus 3. Or you could use a quadratic equation on this if you like. So this gives me two equations, u minus 12 equals 0, or u plus 3 equals 0. We get u is 12, or u is negative 3. So again, after I have the solution to this equation, I go back up with my original substitution that I made, and I have u equals 12, or u equals negative 3, and now I can replace u with a plus 4. And now I can solve that for a. Subtract 4 from both sides. You get a is equal to 8. Here, subtract 4 from both sides. Or a is equal to negative 7. In this case, I only got two solutions to the original equation. All right, let's try one more example. Example 3. X minus 3 equals 2x to the 1/2 power. So this looks a little messy. Let's try subtracting this term from both sides to get all terms on one side. X minus 2x to the 1/2 power minus 3 equals 0. If I line it up like this in decreasing order of the exponent, notice that my exponent here, which is 1, is twice this exponent. Twice times 1/2 is 1. So this is quadratic in form. And you could make the substitution. U could be x to the 1/2 power, the middle variable factor, which means that if you square both sides here, x to the 1/2 squared is just x. So now if I make this substitution, this becomes u squared minus 2, x to the 1/2 is u, minus 3 equals 0. And this I think I can factor as well. Two numbers that multiply to negative 3 and add to negative 2 would be negative 3 and positive 1. So we get u minus 3, u plus 1 equals 0. My two solutions, u minus 3 equals 0, u plus 1 equals 0. We get the two numbers u equals 3 or u equals negative 1. And now that was a solution to this equation. Going back to my original definition, u equals x to the 1/2. Or even you can write it as the square root of x if you want, right? Whichever one you prefer. I'll again write down my two solutions here. U is 3 or u is negative 1. Now you can replace u with x to the 1/2 or with the square root of x, whichever one you prefer. So x to the 1/2 equals 3 or x to the 1/2 equals negative 1. Now you can square both sides. And we'll get x equals 9 or x equals negative 1 squared is 1. Now, notice, because I had the square root, I really should double check my answer in the original equation. I'm doing that because when I had this x to the 1/2 equals negative 1, that kind of alerted me that maybe one of these answers isn't going to be quite right. So if I check back into the original equation, 9 minus 3 is 6, and 2 times 9 to the power 1/2 is also 6. So this answer checks out, and I have a feeling that this one is not going to check out. On the left, plugging it in, you get 1 minus 3, which is negative 2. And 2 times 1 to the power 1/2 is a positive 2. So you get negative 2 on the left, positive 2 on the right. So this one does not check out. It's not actually an answer to the original equation. So there are some cases where you you should always check your answer. This one I definitely wanted to check because I had this fraction exponent there. So that tells me that I need to be careful with the things that I think are my answers that I get. This one I didn't really have to be that careful because I had whole number exponents. This one also I have whole number exponents. So you should always check your answers, but in particular, check that last example.